Welcome everyone. Today I will explore Databricks, a game-changing platform for data teams. Whether you are in data engineering, analytics, or AI, this presentation will show how Databricks simplifies large-scale data workflows. So let's dive in. Here, what we will cover. First of all, we will define Databricks and its core purpose. Then, we will break down its key features, which includes the revolutionary lakehouse architecture, right? We will also look at real world use cases, that why companies choose Databricks and how you can get started. So the question is, what is Databricks? So Databricks was created by the team behind Apache Spark, the open source engine for big data processing. It's a unified platform that brings together data engineers, scientists, and analysts on one collaborative workspace. Unlike Silo tool, Databricks runs natively on AWS, Azure, and Google Cloud, making it scalable and cloud agnostic. Now we talk about the key features. So Databricks stand out with four pillars. First of all, it is Delta Lake, which adds reliability to data lakes with ACID transactions, because it will have no more dirty reads or corrupt data, right? Second one is auto scaling. Clusters expand or shrink based on workload, which saves cost. Third one is notebooks. Teams collaborate in Python, SQL, or R with built-in version control, which means you can go and see the previous versions also. Okay. Now the fourth one is ML flow, which simplifies machine learning lifecycle management from experiments to deployment. So these are the key features. Now we are going to talk about this lakehouse architecture. So traditionally, companies used data lake for staging, because which was cheap, but it was really messy, and warehouse for analytics because it was structured and expensive, right? So Databricks Lakehouse merges both. Delta Lake ensures reliability, while Spark SQL and BI tool deliver warehouse-like performance. So imagine querying petabytes of data as easily as a SQL database. So what Databricks has done, it bring all together data lake and data warehouses in combining and putting into and providing a surface as a lake house. Now we are going more deep dive into the lakehouse architecture and talking about this data lake. Basically, the data lake it's a centralized repository for raw, unstructured or semi-structured data like logs, JSON, and CSV. And the key benefits of this is which stores data in its native format without any schema enforcement. It is also cost effective, which is built on cloud storage like S3 ADLS, right? So another thing is related to this data lake is which is scalable, but there are no AC transaction. That's why it is lacking with the reliability, right? Now we are talking about the delta lake, which means its bring structure is reliable and performance to the data lake. And the key features are ACID transaction, because it was not available into data lake earlier. Now it is available into delta lake, with the ACID transaction, which ensures the data consistency. It also ensures that schema enforcement and evolution, which prevent bad data. Time travel also it consists, which means the query historical data versions. That means you can go and see the previous version of query. It is also optimizing the performance, the file compaction, indexing, right? So why it is matters? It matters because it makes data lake production ready. Okay. Now we are going to talk about the Lakehouse. It's a unified platform combining data lake plus data warehouse capabilities. So the key benefits of this is it has BI analytics, which has SQL query dashboard like Power BI and Tableau, machine learning, which features stores model training, which interfaces, right? Governance for the data security, where you can get the data lineage, access control, auditing, all these things, right? And it will available into built-in Delta Lake. Like built-in Delta Lake means reliability and scalability. So all these features related to Delta Lake and warehouse, Data Lake and warehouse, and Delta Lake will be available into this Lakehouse architecture, right? So why it is powerful? Because it breaks the silos, same data for BI and ML. Means the ETL guy, data engineers and data scientists can be working onto the same platform. Okay, so now we are going to talk about the use cases. So Databricks is not theoretical here. How companies use it? Companies uses it with the ETL, which is extract, transform, and load, which ingest and clean terabytes of IoT sensor data and other kind of data. Right? Real time. It's defect. It's detect fraud in milliseconds, like credit card transactions. Also, it has ML, which train models on fresh data daily. You can think about the recommendation engines, like when we see the YouTube or any other things, where it will, on the basis of your interest, it will recommend something to show you and it will engage more, right? BI, analytics, query live data without waiting for the engineer. So it is similar like a self-service. So now the question is, why Databricks? There are three reasons to adopt Databricks. First of all is speed, because optimized Spark run 10x faster than other cluster, right? And the cost with serverless option means you pay only for what you use. And the simplicity, one platform replaces disjoint tools like Hadoop, Airflow, and Tableau. That means everything you will be everybody will be working at the same platform. And that's a wrap. If you found this breakdown helpful, smash that like button. It helps the algorithm, and share this with more data nerds like you. Comment below with your questions or tag a teammates who need to see this. Subscribe for more content on my channel regarding data engineering, tips and tricks, box fixes, and many more to come. Until next time, happy data crunching.